Okay, let's dive deep into some foundational ideas in mathematics.
Yeah, today we're unpacking sources on factors, multiples, HCF, and LCM.
Right. And our goal isn't just, definitions. We want to get to the heart of how numbers relate.
Finding that common ground, the building blocks. Let's get into it.
So starting with the basics, factors, what are they?
Well, the sources define them as the natural numbers that divide a given number exactly. No leftovers.
Okay. So like for the number 6.
The factors would be 1, 2, 3, and 6. They all fit perfectly into 6.
And for 16?
You've got 1, 2, 4, 8, and 16.
And there's some neat properties here, right? Like 1 is always a factor.
Always. For every single number. And every number is a factor of itself, too.
That structure, that actually defines prime and composite numbers, doesn't it?
Absolutely. Primes, like, say, 7, they only have 2 factors, 1 and 7. That's it.
The irreducible bits.
Exactly. And then composite numbers, like 4 or maybe 10, they have 3 or more factors.
And 1 is special.
Yeah, the sources point out it only has 1 factor. Just 1. So it's neither prime nor composite by these rules.
Okay. Shifting gears then, multiples.
Right. Multiples are the numbers you get when you multiply a given number by other natural numbers, like the times tables, basically.
So multiples of 1 are just 1, 2, 3.
And on, yeah. Multiples of 2 are 2, 4, 6, 8.
And unlike factors, which are, limited for a specific number.
Multiples go on forever. There's an infinite number of them for any number.
Okay, so we have factors and multiples for one number. What about when we compare numbers?
That's where it gets interesting. We find connections. Common factors, for instance.
Factors that 2 or more numbers actually share.
Precisely. Take 6 and 8. Factors of 6 are 1, 2, 3, 6. Factors of 8 are 1, 2, 4, 8.
So the common ones are just
1 and 2.
Got it. And common multiples.
Same idea, but with multiples if you look at 3 and 4.
Multiples of 3, 3, 6, 9, 12, 15, 18, 21, 24.
And 4, 4, 8, 12, 16, 20, 24. See, they share 12 and then 24, and it keeps going.
Okay, which leads us to the big ones, the highest common factor, HCF.
Exactly. The HCF is the largest number that divides into each of the given numbers perfectly.
Our sources had an example, 18, 24, and 36.
Right. The HCF there is 6. 6 is the biggest number that goes into all 3 of those without a remainder.
And the flip side, the least common multiple, LCM.
Yep. That's the smallest number that is exactly divisible by each of the given numbers.
So for 3 and 4, like we saw.
The LCM is 12. It's the smallest number that both 3 and 4 divide into.
And the sources talk about ways to find these, right? Using prime factor.
Yeah, prime factorization is key, breaking numbers down to primes. HCF uses the lowest powers of common primes. LCM uses the highest powers of all primes involved. It shows how tied they are to the number's basic structure.
Now, here's where it gets really cool, according to the sources. The relationship between HCF and LCM for 2 numbers.
Oh yeah, this is elegant. The product of the 2 numbers. So number A times number B.
Equals.
Their HCF times their LCM. Always works for 2 numbers.
They had that great example with 60 and 84.
Right. The HCF of 60 and 84 is 12. The LCM is 420.
Okay, so 60 times 84, that's 5040.
And check this. 12 times 420, also 5040. It matches perfectly.
Wow. So knowing one helps you find the other. If you have the numbers in the HCF, you can calculate the LCM easily.
Exactly. It's a really powerful identity.
And one last quick thing. Co-prime numbers.
Ah, yes. 2 numbers are co-prime if they don't share any common prime factors. Their only common factor is 1.
Like 36 and 175 in the examples.
Yeah. Since they only share the factor 1, their HCF has to be 1.
So wrapping this up, what's the big picture?
Well, we've seen factors and multiples aren't just abstract terms. They're like the DNA of numbers.
And HCF and LCM let us pinpoint specific commonalities, the biggest shared divisor, the smallest shared multiple.
And that amazing relationship between HCF and LCM for 2 numbers. That product rule, it's a fundamental truth about how they connect.
Understanding these isn't just math homework fodder. It feels like it's about breaking things down, finding common elements, understanding structure.
Exactly. Finding the greatest common ground or the least common denominator, so to speak.
Which leaves a question for you, the listener, to think about. How could these ideas, finding the highest common factor or the least common multiple, apply elsewhere? Maybe when you're trying to organize complex information or find the root cause of a problem with many parts, something to chew on until our next deep dive.